Okay, so today we're going to start moving our graphs. I'm just going to jump in with examples. I'm not going to do much with. Yep, I'll do some. Now I'm going to tell you, I'm going to write it like this, and then I'm going to talk to you about it. Okay, what's missing on this? Parentheses. Okay, put your parentheses, guys. It makes all the difference. It goes where? Right there. Now, I promised you that this would look like H's and K's and all that kind of stuff, didn't I? Yeah. Okay, so we have Y equals, and we've always done A. What's A stand for? No, plus or minus is reflected. What's A stand for on trig ones? The amplitude. Okay. On other graphs, it's like the rate of change, right? Kind of the same, right? And we're to sine and cosine are the same, correct? And we're going to have x minus h plus k. What's h do? Left or right? Always opposite direction. What's k do?
Up and down.
Up and down. Now we will start having phase shifts. And when we have phase shifts, I'm going to just go ahead and write it down because you just need to. It will look like y equals plus or minus a sine slash cosine. And it will be b. Oh, I forgot my b in front of my x up here, didn't I? X minus h. Oh, sorry. Bx minus bh plus k. Now, up here, guess what b is? Anybody? If I don't have b and b, guess what it is? It's 1. Down here, b is something. Where is there b? There's b on both of them, correct? So what we will do when b isn't 1, we will factor b out and get x minus h. So when it's b times h, we don't have actual what the phase shift is. What that left and right is. Make sense? Okay. So I have y equals negative 3 minus 2 sine of pi x. Where'd they put the k? In the front. Does it matter? No. If you want to put it in the back, once you put parentheses, can you write it in the back?
Yes.
Without the parentheses, can you write it in the back? No. You can, but it looks kind of funny, right? So, what do we know about this graph? What's this negative tell me? Okay, so it's reflected over x. Actually, I'm going to say reflected over the axis. Because of the thing is we're going to move the axis of the curve, aren't we? Yeah. With h. So I'm going to put reflected over the axis, knowing the axis is in the middle of the curve. Yes? Okay. What's this 2 do? To tell you. The negative told me it was reflected. What's the 2? Amp equals 2. What's pi? No, it's the b. So b equals pi. So what do we go to next then? Period. 2 pi over pi, which is 2. we're going to do scale. We're going to start doing scale every time. Do you guys remember how we did scale?
P over 4.
P over 4. And why is it 4? There's 4 quadrants. So 2 over 4, which is 1/2. So we'll be counting by halves, right? Oh, what's this -3? Tell me. Is that an H or a K? It's a K. So it's going to go down 3. So this is all the stuff that we have to put in this graph. The only thing we don't put in our graph is what? B. But do we have to know B to get the period? Yes. Okay. So in this case, it didn't move left or right, so I will always make this, make my up and down. And I'm going to make my graph look like this. Why am I making my graph look like that? Because it moves down 3, right? So the axis of the curve was at 0. Now it's at what? -3. So give yourself an imaginary axis of your curve. So the amp is what? 2. So it goes up to -1 and down to what? -5. So what I like to do is also give myself an imaginary maximum and minimum. It helps my graph look nice.
That's the plus about doing it online paper. So you can put your
So now it's sine. What does sine look like? What's the parent function look like? Where's it start?
At 0
And goes up.
and then down.
And then down. Oh, and this one I didn't tell you how much. You should have said, how much?
How much?
How much are we graphing? We are graphing.
Enough.
It says sketch the graph. Doesn't tell me how much. So if I don't tell you how much, we're going to assume 1 complete cycle, right? Yes. So this one's not going to start at 0 and go up. It's going to start at 0 and go down. But our new 0 is -3. So just make yourself and make sure you stop on the axis. Don't go past it.
Yeah, Matt.
So we still need all of our critical values, max, mins, and zeros. I always said label 0 even if you don't go through it, right? And what I do is I take it and I make these dotted lines. I would for at least a little bit, because we label things on the x-axis, don't we? Yes. We do not label things randomly in the middle of our graph. That's no.
You don't, I do.
No. You do and you lose points. Okay,
Oh.
so what is our scale? Half. So from wherever we start, and I'm going to say wherever we start because we are going to start moving this left and right also. Okay? We start adding a half. So we started at 0, so we get a half. Then we get 2 halves and 3 halves and 4 halves.
Wouldn't 2 halves
Wait.
be 1?
How about, never mind.
What are you doing?
Never
What are
mind.
you doing?
She doesn't know what she's
2 halves would be 1, yes.
Yeah.
Then 3 halves and 4 halves would be 2. I was like, wait a second. And I stopped because where should I end? 2. Only because I started at 0. But when I go, I'll show you a trick for when we move it left and right. You'll take your ending and your starting and subtract them, and you better get your period. Because if you don't, then you added wrong. So not much difference, just up and down, right? Okay. I'll do another one up and down. Y, oh, H. This one has like a story problem. This would be a story problem one. H equals 139 minus 125 cosine of pi over 10t. Reason I know this is off of a story problem is because we have things like H and we have T that always stands for time. Okay, so we gotta go through it. Is it reflected? Okay, reflected. And if you want to put H axis, you can. What does H stand for?
Height.
Horizontal.
I was close.
How about we do this?
Oh.
Okay,
Just so Blake knows.
now, Savannah didn't fall for it. 139 is a what?
Okay.
It's a K. Some people like to list their H and K's first, whatever. Okay, amp,
125.
never make it negative. B,
Pi over 10.
P, 2 divided by pi over 10, or multiplied by 10 over pi. You know that you did this wrong when you get pi squared, guys. Can you get pi squared as a period? No. Okay, now what? Scale. And that's P over 4. I'm going to write that because we haven't done it much. So 20 divided by 4, so it is 5. And what does my 129 tell me? 139. Up 139.
Where do you have it written up there with the H or the K in front? Is that where we're gonna have it in the book?
A lot of times they do in the book, especially when A is negative.
Okay.
And if you want to rewrite it, I don't care. I don't care. Just remember it's positive and. Okay, so this thing we're moving up, right?
Yeah.
Are we gonna hit the x-axis?
No.
So this is the great thing about sketching a graph. Because I can say, look at this. 139.
It's not 139. It's farther.
Actually, that is really high up. I don't want it there. I don't want that. Okay, so what's my amp? 125. So how do I get this number? 139 plus 125. So
184.
264?
Yes, 264. Yeah.
125 and 139? So how do I get down here?
139 minus 125.
And don't touch the x-axis, right?
14.
So it's 14. With that scale, I should be even closer, shouldn't I? Okay, so it's cosine. So cosine What's its parent function look like?
Starts at the top.
Starts at the the max and goes down and goes back up, right?
Parabola.
But this one's what? Reflected.
So it's gonna start at 14.
And it's not left or right, so we're going to start here at 0.
Mhm.
And guys, you make your, if you notice, like every single one of my graphs look exactly the same, just the units change. Make your unit, like especially this, make it fit your graph, not your graph fit it. So bring this stuff down. Oh, no, I switched. Oh, I do know I switched. Bring this down. Always 0 no matter what. Always put your ends on your positive. So my scale is what? 5. So on the bottom it's going to be what? 10, 15, and 20. Okay, so y equals sine of x plus pi over 2. So now what's changed?
We're going left.
And we're going left pi over 2, aren't we? Okay, reflected.
No.
And I always do no reflect. I like take an account for it. Because if I don't, then I tend to forget. Okay, and then amp.
No.
Did you say 1?
Yeah.
Okay, B.
1.
And so period.
2 pi.
Even if they're the same, when I grade these, when you guys take your test on Friday, I grade every single one of these things.
You already have a test?
Yes. It's only part of the chapter. Okay, and then scale.
1.
Pi over 2, yeah. 2 pi over 4 is pi over 2. And we're going left. How much? Pi over 2. Going up and down at all? I finally got it. I normally do all my work here and then graph right here. So on my piece of paper, like on my notebook paper, if you'd see it, I do my work here and then my graph would go over here. And my work here, my graph would go over here. This one's going left. I'm not going to put my y-axis. I can put my y-axis in anytime, can't I? Okay. It's not going up or down. It is sine. So it starts at the axis and goes up or down. So is this going to go up or down? Up. So just give yourself a sine curve. Oh, do you guys want to put your top and your bottom?
Yes.
Yes? Okay. Sorry. Because we didn't move it up or down, I didn't think. So give yourself a 1 up and 1 down, right? We aren't going to label it till we put a y-axis. But I like this a lot, even on my line paper, because then I know where I'm going and it doesn't look so horrible. Okay, now draw yourself a sine curve.
go up first from the y-axis, not down?
That's right there.
Or we went back?
But it still starts here, doesn't it?
'Cause
It doesn't start at 0 now. Where does it start?
pi over 2.
So it still starts at the axis. Oh, and I did forget to tell you, it told me to go from negative pi over 2 is less than equal to x, which is less than equal to 3 pi over 2. Okay? So I don't really know what that is in the scheme of my things. So I'm only going to give myself one curve, and guess what I'm going to do to it if I need to? Just add on. Can you guys see if I label in green? Can you see when I write in green? Not that one. I was trying to get a different color. Okay. So I know I normally would start, this would be 0, but I'm going to subtract pi over 2 because I'm going back, right? So 0 minus pi over 2 would be negative pi over 2. And so we're going to need to have this, and this, and this, and this, right? Well, then I just start adding my scale, which is pi over 2. Pi over 2, negative pi over 2 plus pi over 2. 0. Yeah? So now, guess what I put in? I put my y-axis. Because I know where it goes. See how I'm making my labels fit my curve, not my curve fit my labels? I will have people that go and do the labels and then they make this curve and it's like disgusting looking. I would like all nice and pretty sine and cosine curves. Okay? Make your labels fit. If you're going to have lots of labels, don't make it teeny, make it what? Big. Okay, so now I could also label my y-axis. What's my max? 1. What's my min? Okay, and then I keep adding my scale. So 0 plus pi over 2 is pi over 2. 1 pi. And then 3 pi over 2. Now, do I have to add anything to this? Have to add anything to this curve?
No.
Nope. What if I told you this?
Still no. You have to add one more.
I have to add. So I'd have to go up here, which would be 2 pi. There's some times where they don't want 2 pi, they want like, oh, you get something, like 5 pi over 4. No, 7 pi over 4. Well, 7 pi over 4 would be like right in here, wouldn't it? So you have to mark it 7 pi over 4 and erase back to where it would be. So sometimes you gotta watch that. That's kind of tricky when they do that. Okay. So here, the scale really does help out. So y equals cosine of x minus pi over 6. And this one says 1 complete cycle. So is it reflected? No. Amp? B? Oh, yeah. B?
1.
Period.
2 pi.
I hate recording.
Okay, scale.
Pi over 2.
And left, right, up, down, backwards,
Right, 5 or 6.
right. 5 or 6. So now I can put my y-axis, just because am I going to be touching the y-axis anymore? Because I'm going where?
Right.
Right. Now, if it was more than one complete cycle, then you might. So be careful of that. Sometimes you just get an axis as a curve. I don't know why I'm making them so big. So our amp is 1, so give yourself a 1. And a -1. You guys like giving the boundaries? It's cosine, not reflected. So is it going to start at the max or the min?
Max.
Max. So give yourself a curve. What did I forget on my y-axis?
0.
0. Okay, so I moved right pi over 6. So I start at what?
Pi over 6.
Pi over 6. But I'm adding what?
Pi over 2.
Which would be 3 pi over 6. So should you have common denominators? Yes. So 3 pi over 6 plus 3 pi over 6 is 4 pi over 6. I'm writing it down here. Why do you think I'm writing it down here? So I'm going to have to reduce, and I'm going to have to keep track. So then 4 plus 3 is 7 pi over 6. And then 10 pi over 6. And then, and that way we could just do it evenly and then go back and reduce, right? So I get, what, 2 pi over 3? And 5 pi over 3. Now, how do I know my period is still 2 pi? Because I didn't end at 2 pi. To check your period, you take the ending minus the beginning, and you better get the period. Did I?
Yes.
Now, we didn't get to the really hard ones. They're not hard, but that put everything together. I'm trying to look where that starts. It's not too far in. I will record some examples so right now you're good till you get to 23. I will record examples for 23 and on and post them. Okay? Do not wait to do work.
That's right.